So here we are trying to review for this test over quadrilateral area and a polygon area. Okay, so hopefully you know all of your formulas because it's basically just a formula test. So starting with number one, what kind of a shape is it? Oh, it tells you what kind of a shape it is. It's a parallelogram. And the area formula for a parallelogram is just base times height. Okay, so here 11 represents your base and 6 represents your height. So quite simply, 11 times 6 is 66 square units. Okay, since we're not given units in the problem, you have to just assume that they are some type of a unit. And area always has a squared unit. It is a length times width, a squaring of the units. Okay, and number two, what's the area of this triangle? So hopefully you notice you know 3 sides of your triangle. And whenever we know 3 sides, whose formula should we be using? Heron's formula. Okay, which is a square root of a lot of different subtractions. So the first part of Heron's formula is finding your semi-perimeter, which is literally half of your perimeter. So we're going to take our 3 sides and add them together and divide by 2. 7.85. So now that we know that, we can go into our Heron's area formula. It starts with the semi-perimeter, and then it has the semi-perimeter minus every single side, and then multiplying them all together. So 7.85 minus all the other sides. These are all minuses in here. Minus, minus, minus. And then you multiply them all together. So I'm going to let my calculator handle all of this, and it's going to give me an answer. My calculator says 8.92859. So 8.929, and we don't have any units. So once again, squared units when we round to 3 decimals. Okay, now in my class, it's okay if your last decimal might be different, but some teachers want the exact number as them. So good luck with that. Okay, number 3, what's the area of the quadrilateral below? So we have it on a grid, and whenever we have a shape on a grid, we use Pick's formula. Okay, which says you take the number of interior points and you add it to half of your border points, and then you minus 1.
There are 6 border points.
So let's see how many. 1 here, right? There's none. And then 2, we come down. Oh, wait, I see 3, and then 4, and then 5. And then anything along the bottom, nope, 6, and no. So we can always double check and just look at the slope, right? We look at the slope of our line, and if it can be reduced at all, that means we have more points in the middle, right? These 2 sides, the bottom and the right, are 1 down, so there's nothing we can reduce. But this side is up 6 over 3, right? Up 6 over 3 reduces to 2 over 1, so we know there's going to be some border points in between your ends because your slope can be reduced. And then, of course, this one on top is a 1 over 5. So there are, in fact, 6 border points. So we can change this B to 6 because there are 6 of them. Now, how many interior points, right? We really got to be careful and count every single point on the inside, starting with this guy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 in case I lose count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. 1, 2, 3, 4, 5, 6, 7. 47. I agree. There are 47 interior points. So 47 plus half of 6 is 3. That's 50. 50 minus 1 is 49 literal square units. Every one of these is 49 squares. Okay, so anytime we have a shape on a grid, you can employ Pick's formula in order to find out the area. Just make sure that you really do inspect the interior points and get all of them. Okay, and of course, if you're missing one or two, well, one, right? If you happen to miss one and you show me all your counting, then you won't miss that many points off of the problem. Okay, but if you just throw a number up there and it's wrong without any dots or anything on the page, then you're going to get it all wrong because you didn't show me your thoughts. So, number 4, find the area of our triangle. This one should be a giveaway as to which formula to use. The trig area formula, which is 1/2 the product of your two sides times the sine of the angle in between them. Okay, this angle is always between your two sides. So we're going to plug this into our calculator. 1/2 of 7 times 13 times the sine of 52 degrees. 1/2 of 7 times 13 times the sine of 52. And make sure you're in degree mode, because if you're in radian mode, you're probably going to come out with something completely different. And my calculator says 0.8545.
So 8.55.
So we're going to round up to 8.55. And since we still have no units, square units is the area. Okay, so depending on what information you're given for these triangles, you're going to use one of the different formulas for your triangles. Okay, a regular octagon that has an apothem of 6. So in our apothem, or our regular octagon formula, that's 1/2 of A, the apothem, times the number of sides times the side length. Right, maybe you see the formula 1/2 of AP, 1/2 of the apothem times the perimeter. Well, the perimeter is made up of two parts, the number of sides, which you can count, and the side length, which in this case, we're going to have to calculate. Okay, so we know the apothem is 6. We know this bottom side is 1/2 of your side length. And we need to find the angle for your trig triangle. Okay, and that angle is always 180 divided by the number of sides, or 360 divided by twice the number of sides, which comes out to be the same thing. So for an octagon, that's 22.5 degrees is your trig angle. So it's always 180 divided by the number of sides. That's what we're going to use in our trigonometry. Okay, so for our 22.5 degree angle, the apothem is the adjacent side and half the side length is the opposite. So we're going to write a tan relationship in order to calculate our missing side. So that's 1/2 of your side divided by your apothem. Oh, your apothem we know is 6, so we can put that in there. So if you don't remember what the fancy formula is, you can always set up your tangent, your trig ratio here, because it's a right triangle. Your apothem is always the perpendicular bisector of the side of your polygon. So it turns out the side length is always 2 times the apothem length times the tangent of your angle. Okay? When you solve this for S, this is what we get. So 12 times the tangent of 22.5 gives me a side length of 4.97. We're going to keep all the decimals in here, 0.56. So that's the length of our side for your octagon. So we know the apothem, we know the number of sides, and we know the side length, so we can calculate the area of your regular octagon. Okay, apothem was 6. How many sides does an octagon have?
8.
8 sides, right? We can count that. 8 sides, and our side length was 4.97056. So I'm going to stuff all this into my calculator and see what it gives me. 119. Where can I write it? I'll write it over here. 119.294 is what my calculator says, and looks like we have meters as the units. So square meters. And if you rounded back there where you found your side length, you're going to get a slightly different answer. Maybe 120 or maybe 119.6, a little bit higher or a little bit lower than what this is. So on your test, as long as you show me your side length, the number that you're actually using to calculate it, I will give you full credit. Now, if you don't show me that, you just slap a number down there. Chances are you won't. Get as much credit as if you had shown me your thinking. Okay, number 6, looks like we have an algebra problem. We know the area is 39, and it says find x. So we want to figure out what the length of this base is. So our formula says that the area equals 1/2 the sum of our bases, so 9 plus x, times the height, which is 6. Okay, 39 equals half of base 1 plus base 2 times 6.
Times 2, right?
So we're going to multiply by 2 to get rid of the 1/2, right? That's pretty standard operating procedures. 39 times 2 is 78. And now on the right side, we're going to distribute our 6 into both of your things here because there's a plus. So 6x plus 54. Okay, so algebra would say now we subtract the 54 from both sides. And then 24 equals 6 times some number. So dividing by 6 means we have a base length of 4 centimeters. Okay, so here's a little algebra, right? We cannot combine the x. This is not 9x. Remember, 9x is 9 times x. This is x plus 9. Those are not like terms, so you cannot combine them into one thing. So leave the plus. The trapezoid formula is the only one that we're adding in. So there's a plus in your trapezoid formula. Okay, the quadrilateral and the octagon below are both regular. So what is a regular quadrilateral? Yes, and which quadrilateral has equal sides and equal angles? A square does. So we have a square and an octagon. The area of the quadrilateral, aka square, is 16. So 16 equals side squared, so that means our side is 4 units long. Okay, 4 and 4. What's the area of the shaded triangles? So to me, maybe that looks like, hopefully as to you too, if I took my squares area and subtracted my octagon, would that tell you what all 4 of those triangles added up are? I think so, because figuring out what this much is of your triangle is probably not going to be very easy. But if we found the area of the octagon and just subtracted it from 16, the area of the square, then we could get all 4 triangles at once. So let's do that. 1/2 of AP, yes? Or A times N times S, just like we had up above for a regular octagon. What do we know? Do we know the side length? No, because this is the side length here. This is the side. We don't know what that is. Do we know the apothem? Where does the apothem go? From the center, perpendicular to the side. What if I put 2 apothems on here, top to bottom?
Cut it in half.
Oh, I kind of do know my apothem, don't I? The apothem is going to be 2 because it goes from the center, which means it's half of my side length. That's a pretty important concept to understand here, that the apothem of your octagon is half of your side length. And now I think we can do pretty much what we did up above. The side length is 2 times the apothem times the tangent of 22.5, right? That's the exact same formula that we had up above on number 5. On number 5. 2 times 4 times the tan of 22.5. So 2 times 4, that's 8, times tan 22.5. This gives me a side length of 3.31371. Okay, so you might have been thinking, is this half of the whole? No, the side length is not half of your square. The apothem is half of your square, and this turns out to be way more than half of your square, more than 75%. It's a good thing I'm doing this with students. 2 times 2. Yes, that's very good point. Very, very apropos, if you will.
Times 2. Oh, it's a pocket.
So if I divide this by 2, that means I have a side length of 1.65685. Does that sound better? I think so. That's a pretty short side length, but that's okay. So then my octagon, I'm going to draw an octagon. The octagon area is 1/2 of apothem, which is 2 times how many sides? 8 times a side length of 1.65685. So I'm keeping all those decimals in there. So if you rounded, then you're going to get a slightly different area than I am, which is 13.2548, which is 13.255. Is that what it was up there? That 255 sounds familiar. Where would that come from? It was 855. Anyway, I digress. So the squares are going to be a 16 minus the 13.255. So if we subtract 16 minus 13.255, that means all the triangles are going to have areas combined of 2.745. And my units are units. Okay, so there's a lot of work in this one, right? There really shouldn't be a number 7 type question. This is a lot of thinking that we're doing here as we go on. But to find the area of the shaded stuff, you take the square and you subtract the octagon. So we had to do all the work to find the area of our octagon, which is good practice, right? That's good practice to do, finding the area of your octagon. Okay, number 8, find the area of a heptagon. So how many sides does a heptagon have?
7.
7. We can count it. 1, 2, 3, 4, 5, 6, 7.
180 divided by 7.
So let's draw in your apothem. Right, here's your apothem. And we know the side is 10. So for our right triangle here, we're going to have a side of 5. And what is our angle that we're going to use for trigonometry?
25.7.
Right, a decimal. 180 divided by 7. We're just going to round to 1 decimal for ease of calculations. 25.7. So that's the angle that we're going to use when we calculate your apothem. Okay, so once again we have a tangent because we have the opposite side and the adjacent side. 5 over a, the opposite side is 5, and the adjacent side, your apothem, is a. So your apothem is half of the side length divided by the tan of 25.7. And I am putting 25.7 into my calculator, and I have an apothem of 10.3892, which I'm just going to leave as 10.389. So I have my apothem, I have my side length, I know how many sides it has, I can calculate the area. 1/2 of apothem, 10.389, times how many sides in a heptagon? 7, good, 7 sides, and a side length of 10. Okay, so I always try to use the same formula, 1/2 of apothem times number of sides times side length. Okay, so we stuff this all in our calculator. And I come up with an area of 363.615 miles, square miles. Okay, so using formulas, right? We have to use the correct formula for the problem that we are using in order to find the area. Okay, so the other side is going to be on the next video, so check that one out too.